The topic of expanding universe. For that, we need to look at the model, which is the accretion model of the solar system. So as we said before, that the star or solar star, the sun, was formed from the nebula cloud, which was a cloud of gas and dust. And then gravity pulled the gas and dust and concentrated it into the center of that cloud to form a ball in the center made out of hot gas and dust. So this hot gas and dust kept condensing and compacting due to gravity to form the sun, or the protostar that we know now as the sun. So after a few million years, it became the sun with some rocky planets and icy bodies around it, and now 100 million years later we know it as the solar system. So those rocky planets are usually smaller planets like Mercury, Venus, Earth and Mars, and they are nearest to the sun. The gaseous planets are large in size, more high volume, but less dense, like Jupiter, Saturn, Uranus and Neptune, as they are further away from the sun. The difference between those planets are defined by the accretion model in this solar system, and this is what formed our solar system, starting from the nebula, which was caused due to the gravitational attraction that pulled all the cloud of gas and hydrogen to the center. So our solar system was formed around 4.5 billion years ago, and planets were formed from the remnants of that cloudy disk, and the leftover of the nebula. So gravity basically collapsed the matter from the nebula on itself, causing it to spin in a disk around itself, and then forming the sun in the center of that disk. And this is called the accretion process, or accretion process, or accretion disk. Now let's talk about another concept in physics, which we call it the Doppler effect. So the Doppler effect is related to emitted waves. When we have waves emitted from a stationary object, we expect them to spread out symmetrically. So if you look at the length of this wavelength, you can see that is moving or propagating in a symmetric wavelength. If the object starts moving, then we know that this will affect the wavelength of the object, sound or light frequency. So we can see that the car moving with a certain noise or sound, the wavelength gets longer for the observer moving away from the object, and it gets shorter for the person or the observer near the object. So if the car is moving in this direction, the observer right here will have a higher frequency and a shorter wavelength, and the observer on this side will have lower frequency and longer wavelength. And this is explained as a Doppler effect. Now let's link it to the Big Bang theory. So the Big Bang theory suggests that the universe was created 4 billion years ago, and then this was created due to a small, very dense point with a very extremely hot and dense mass, and due to a big giant explosion, there was the Big Bang that created the universe that we know right now, and the universe kept expanding from that single point to be this universe that we know today, which is much cooler and much larger. So the expansion of the universe did not stop at any point. It kept growing, as we know that the galaxies are moving away from the observer, which is the Earth, every day expanding. So this phenomena caused something that we know in physics as the redshift of light from the distant galaxies that are far away from us when we observe them from Earth, which was supported by the redshift theory that support the Big Bang theory as well. So that means that the universe is continually expanding or continually moving and growing. So let's talk about what is that redshift concept. It discusses the Doppler effect as well in terms of the light wavelength. So when we look at light, the shorter wavelength of light would be more on the bluer side, and then longer wavelength of light would be more on the red side. So as the object is moving away from an observer, the wavelength of light will increase, and it will become more in the red zone here, or red shifted to this red zone. And now this redshift means that we are always increasing the wavelength between the observer and the emitting source when we are observing other neighboring stars and galaxies. So this trend was observed in almost any distant galaxy or distant star that we observe from Earth, where all of them were redshifted, which means that they are all of them are moving away from us as Earth when we observe them. So that means that the universe is actually expanding, where the distant galaxies are still expanding and kind of moving away from Earth. Yeah. So this concept is called redshifting, and it supports that our universe is expanding over the galaxies are moving away from our solar system, or kind of being expanded away or stretched away from our solar system when we observe the light emitted from them. Yeah. So all galaxies appear as they are redshifted when compared to the light emitted on Earth. Yeah. So in that case, if we are observing from this point of view, when we look at the object moving away from us, you can see that the wavelength is increasing, so that means it's redshifted. And if the object or the galaxy or the star is moving near us on Earth where we're observing it, we will see it as blue shifted, which does not really happen in our case or in our universe. Yeah. So that concept can be explained using a simple diagram of a balloon representing the fabric of space, where the balloon would expand as it grows, and as we have planets scattered on the surface or the fabric of that balloon, the distance between galaxies will stretch, which means that the universe itself, represented in that case in the balloon, is expanding, which is supported by the Big Bang theory in that case, where we say that the galaxies are getting away from us and the distance is getting greater and greater every day, which means that the universe is still expanding, yeah, and moving further away from us. So in summary, we can say that the redshifting is an increase in the observed wavelength of any electromagnetic radiation emitted from a star or a galaxy. Yeah. Now let's look at the light emitted from a distant galaxy. So if we talk about the light emitted from a distant galaxy, it appears to be redshifted in comparison with the light emitted on Earth, which means that the universe is expanding. Yeah. So when we talk about redshifting, we can say that the light from a distant galaxy is an evidence of the universe being expanding, and also it supports the Big Bang theory as well.